Hi everyone, welcome back to the channel. In this series, we are going over Leetcode problems, and today we are looking at Leetcode number 11, container with most water. The problem states you are given an integer array height of length n. There are n vertical lines drawn such that the two endpoints of the ith line are I and 0, and I and the height of I. Find two lines that together with the x-axis form a container such that the container contains the most water. Return the maximum amount of water a container can store. Notice that you may not slant the container. So if we look at example number 1, we see the max area here. And when it means you cannot slant the container, that means that we wouldn't be including this extra portion because a container can only hold as much as the lower height, otherwise that water would overflow. So as you see in like this section, the water would overflow here, and we only want to use the smaller of the two heights to calculate that. Okay, so one way that we can do this is by using a two-pointer approach. And what we'll do is we'll set one pointer at each side, and we're going to iterate through the array inwards, and we'll move our pointers inwards, calculating the max area or the max amount of water that we can keep or contain in those areas using the width, which will be our pointers subtracted, so it would be like our right pointer subtracted by our left pointer, and that's going to be our width, and then we're going to times it by the lower height. So the lower height of each of our values. So to get started, we know that we want to keep track of a max area variable, and that's going to be max area of 0 as we start out. And then I want a left pointer, and that's going to be our very first index, which is 0. And then at my right pointer, that is going to be at the end of the array. So we'll do length minus 1. And for our loop, we're going to use a while loop. And we're going to say while our left is less than our right, because if they ever pass each other, we know that we've already seen the values there. So we want to make sure our left stays on our left and the right is on the right. And just to make things a little bit clear or simple, I want to pull out the values, so the height of our current pointers. So I'm going to say left height is the height at our left pointer, and our right height is equal to height right. And now I want to calculate the area. And our int area is equal to right minus left. So like we said, the right minus the left, that's going to give us our width. And to find our height, the height that we want to use is the minimum value that we said. We want to check the two heights that we were comparing and use the smaller one. So for that, we're going to use the math.min, so which is our math class in Java. And we can pass in the left height, the right height, and whichever one is smaller, that's the one that will be used for our height. Then once we have our area, now we want to update our max area with whichever is greater between our current area and the max area that we already have. And again, we can use the math class for that. It's very helpful in this situation. And then once that max area is created, we will need to then move our pointers to a certain, either move them upwards or move them downwards. And we can do that by just checking whichever of our pointers is smaller than, or the height is smaller than the other one, we'll pick that one to either increase or decrease. So we'll say if left height is less than our right height, increase our left pointer. Otherwise, we're gonna decrease our right pointer. And this is also gonna cover the instance that maybe they're both of the same height. At that point, it doesn't really matter. You can still either choose to increase your left or decrease your right, but we're just using this as a way to decide how we're going to move our pointers along. And as we move our pointers along, that will continue on while it's in that while loop, while our left pointer is less than right. And then eventually they will meet and we'll exit from the while loop. And at that point, we can just return the max area that we've found so far because we have been keeping track of that max area. And we'll go ahead and run this. And our test cases pass. And this is a O of n time complexity as we are only going through our array once. And we didn't make any other data structure. We're keeping variables, but there's no other space complexity. So this is an O of 1 space complexity. And that is all for this Leetcode session. If you have any questions or you enjoyed this content, feel free to comment or like below. And I will see you in the next video. Thank you.